translate. So, well, we are here to thank you very much, Mariana and Prime, for invite us to the webinar. We will present today the battery 200 kilowatt hour from Huawei. We will show you a video, but let me start showing a mock-up. This is the 200 kilowatt hour battery with the PCS, the power converter, 100 kilowatt, and air conditionings in the doors. And if you open, we open. Okay, the good one, the doors are not removable, of course. You can see 12 battery packs that you have to install during installation. Each one of these battery packs is 16 kilowatt hour, total of 12. And Alejandro will show you in some slides when all the key systems for security, for controlling and optimize the power of these batteries. Just to show you and have an initial idea of what product we are talking today. So, and let us start before the presentation with a video. It's a short video, but it's very well done, and we'll show you in detail all the product. Let me click. Okay, this is the battery at a glance. Only to say before Alejandro starts with the slides that this battery is already in the market. We have delivered a dozen of units in Spain, and we hope soon we will install our first units in Portugal with the help of Prime. So Alejandro, your floor, and I will help you for the Q&A, but let me go to the slides. Sir?
Yes. Well, thank you very much, Jesus. I'm going to be proceeding now. I'm going to be doing the presentation for the battery system. So first of all, a little overview on Huawei, the company. I know we already know these very well. We know the company, so we're going to do this very, very briefly. So Huawei is a company that has over 190,000 employees and has presence in over 170 countries and region. It's made it to number 96 in the Fortune Global 500 and is number 2 in research and development investment. We can notice this because over 50% of their employees are in research and development. It has focused on information and communication technologies to provide products, solutions, and services for customers, carriers, and enterprises in several different areas like devices, connectivity, and digital power. And it has a solid operation and worldwide recognition, a stable business growth, and we have seen how they're integrating digital and power electronics to promote green energy usage. And we can see this very clearly with the smart PV solution, combining PV and energy storage, which we're going to be analyzing deeper today. And in regards to the research and development team, They have over 12 research and development centers around the world, and over 10% of the earnings of the company are invested back in research and development. Now we move forward to see a little bit of the industry insights, to understand a little bit of the market that is driving the batteries and the incentives that it is receiving, and why this is happening, and which business models are available for this. First, we have to talk about carbon neutrality. There is a global consensus. There is really no discussion whatsoever on that we need to reach carbon neutrality. And all of the major economies have a goal for when to be carbon neutral. It's not about if, but about how and when. We see this in China, the European Union, United States, and Japan. They all have carbon neutrality targets. But this is not only true for state level policies. We can also see these for enterprises, top companies, that all of them, well, many of them, many non-big companies have established also carbon neutral goals, like Google and ABB and Amazon. And not only that, but over 400 companies, well, nearly 400 companies have joined the RE100 Alliance, and they are committed to use 100% green electricity. And in all of these contexts, PV has become quite the trend, because PV is a reliable energy source. It's being proven, it is cheap. However, PV by itself, it cannot provide all of the energy, all of the green energy to satisfy your demand, because the curve of generation of a PV system has a peak in the morning and doesn't really usually match the load consumption of companies and households. So this is when batteries become important, because this way you can use the energy that you use, that you overproduce in the day, during the day, in other moments when you need it. But this is not the only reason that is driving batteries, but also as we increase the penetration of solar energy and wind energy, the system becomes more unstable, because these energy sources are
Alejandro, sorry. Can you click on ocultar on the?
Oh,
yeah, just to not show the bar. Yeah,
thank you very much. Yes, sorry. So we move on. As I was saying, because there is now variable generation and variable demand, adjusting demand and consumption can be harder. And this is how batteries can come to assist the grid to make it stronger by providing balance of system. And this is the reason why several policies are being introduced all around the world to assist energy storage deployment. And these policies, they come in the way of tax breaks, in the way of subsidies, and they're happening all around the world in many different countries like Spain, Japan, and China.
Even in Portugal.
Even in Portugal too is happening, because it is becoming a necessity to have this balance of system. So now, what is the business case? What is the business case that support the installation of these batteries? And the ones that can also be supported, all of them, by our battery. We have maximum self-consumption, which means using that the energy that you don't use during the day, you can use it at night. And you just need a price of 50 cents per kilowatt hour. So you have a return of investment in under 5 years. Ancillary services, which would make more sense for countries that have frequency regulation market, and with a price of 18 euros per megawatt per hour, it's also under 5 years of return of investment. Time of use, when you observe energy during valleys of prices, when it's cheaper to use it when it is more expensive. And if you have a price difference of 15 cents per kilowatt hour during valley and peak, you can also have an under 5 years return of investment. Demand management, which can be seen here in the form of peak shaving. So you have a high peak in demand and you want to use energy from your battery because there is a charge for power. And with a demand cost of 130 euros per kilowatt per year, this return of investment can be done in under 8 years. And also avoiding grid reconstruction, because as productivity increases, so does demand, and so does the requirements of the grid that these sources are connected to. And this would mean replacing or increasing the inverter capacity, the transformer capacity, power lines. And this is not only costly, but can have a duration of up to 6 months. With a battery, you can manage the demand, so you don't have these peaks in consumption for the grid. You can reduce the stress, and not only do you save money, but also this battery can be installed in a week, while this reconstruction can take up to 6 months. And this is, in theory, the business cases, but we can see them in practice how they're becoming more viable. Maximum self-consumption, for example, has become quite the case to analyze, because with increase of prices since the last year in electricity, this business case is making more and more sense. An example of this is in Greece, for example, where you can see that a PV system only have a return of investment of 1.7 years, while adding storage, it only increases that in half a year, and you can have a 19% increase also in the return. So it does make sense. Ancillary services for Portugal and for Spain, they would not yet make sense, because you would need a market for frequency. But in countries where this market exists of frequency regulation, we can see like Sweden, for example, where price increases up to 50 euros per megawatt per hour. The return of investment is under 2 years. Time of use mode, this one is quite interesting, because we saw before that for under 5 years, we only need a 15 cents difference. In Portugal, this difference is of 19 cents between peaks and valleys. In Spain, it is of 37 cents. So there is a business case for this to have a return of investment that is quite good and below 5 years. Here we see a case, it is 11 cents for other countries, or it can be a bit higher, and the return is in 8 years. Demand management. So here would depend a lot on the case. In countries like Germany, for example, and Japan, there is higher investment for higher power cost. In Spain, for example, it might be lower. I don't really know what it would be the price for Portugal. However, it is important to know that this business model does not exist in isolation from the other ones. You can have peak shaving, and you can also have the other business models being applied, time of use and maximum consumption. And also the peak shaving for avoiding grid reconstruction. And this will become more relevant in the following years, because the tendency of electric vehicles and the tendency of we want to charge our vehicles weaker, so we need more power. So we are also increasing the peaks in power. All of these would make more sense of the case for avoiding grid reconstruction with batteries. But as I said, all of these is not either one or the other. You can have more than one of these business models implemented with the battery. So there have been some challenges in the past with batteries, and these challenges are perfectly addressed with the 200 kilowatt hour Huawei solution. We will be seeing how this is done. But what are these challenges that have appeared for other batteries? Well, safety risks, for example, concerns that there might be a fire in a battery. Maybe once you might have seen in the news some battery that might have happened to, or low battery utilization, that the battery life is usually shorter than that of the power station, and complex operation of management. These problems do not exist for the Huawei battery solution, and we will see how each one of these is perfectly addressed. So now let's talk about the battery. Let's talk about our product. First, to mention that it is a solution that can be useful both for grid-connected business mechanisms, but also for isolated, off-grid functioning. For the grid-connected one, is a one-fits-all solution. As I mentioned, all of the previous business models that we discussed can be implemented with this battery, and all of the components you need to make this configuration happen, we can provide at Huawei. From Wattkraft also. So the energy system, meters, the SACU, inverter, and optimizer. For operation off-grid, which is also perfectly possible, and it has also been implemented so that there's energy during outage. This would require also third-party controllers that are perfectly compatible with the Huawei solution. And there's active safety. So we have several safety layers to avoid this picture that we saw before of another battery in fire to happen. More energy, there's optimization within the battery that leads to 5% more energy than other batteries of the same capacity, and smart operation and management that would not require the complex O&M that other systems require. So going deeper into the battery, first, we can see that we have a door-mounted distributed air conditioner. We have two of them, one in each door. And this is in order to have a more distributed cooling effect within the batteries to avoid high differences of temperature within one pack and the other, which is extremely important to have homogeneous operation of the battery. Inside, we can open it and we see that we have 12 battery packs, each one of them having 16 batteries of 320 ampere hours. Each of these battery packs has an optimizer, so they can perform at their best capacity independent from the other. And they are all together in one battery rack and in one cabinet. And then all of these batteries from this battery rack are connected to the DC-DC converter that we see in number 4. So in number 2, we have all of the batteries performing at their best capacity individually, and then they're connected to a DC-DC converter so that you can have the optimum voltage in the PCS, which is the power converter system. It converts from DC to AC for discharging and AC to DC for charging the batteries. And there's also the emergency stop switch. This battery is to be used outdoors. However, if you have a room that is specialized only for the battery, it can also be installed in there. The battery is actually quite safe. It's just a measurement that Huawei is taking for now for the product, just to see how it's operating, but it is perfectly safe to have. And to go a little bit more into the components, here we can see the battery pack. It is lithium iron phosphate, the material, and has a rated voltage of 57 volts. And each one of them has a 16 kilowatt hour capacity and weighs under 140 kilograms. And the smart PCS, it is of 100 kilowatt. So the battery has a capacity of 200 kilowatt hour. This means that you can discharge the whole battery in 2 hours. It is a 0.5 rating. It has an output voltage of 400 volts in AC and 1100 voltage in DC that comes in, and an efficiency maximum of 98.5 and error efficiency of 98.2. Now, deeper into the safety mechanism that we mentioned before. So most of the solutions that are currently in the market, the only safety risk management that they have is a centralized fire extinguisher, which means that there needs to be a fire for something to happen. And we don't want to get to that point, which is precisely the solution that we have in Huawei. The point is, do whatever we can do beforehand, so there's no need to suppress any fire. So there is the pre-warning, there is a cloud battery management system that has 24-hour pre-warning for any thermal runaway. So it's registering the behavior of the batteries. And then there is the detection. There are several sensors in the AC, inside the battery, that will make sure what are the cell operating parameters. And in case that one of these cells, they see that is operating in a rate that might result in a fire, we have isolation. So this is the third step. If one of the cells we see that there's any risk on it, then it is isolated from the others. And this will not affect any of the other cells. So if one of them has a defect, then the others will continue generating normally, and that one is going to be isolated to avoid any problem. And finally, in the case that even all of these fails, there is a fire suppression mechanism that will avoid, as soon as a fire starts, it will immediately act in the first 10 seconds and will suppress any fire. So it is a very, very secure battery. But about the more energy, we mentioned before that this has a 5% more discharge capacity. How is this? Well, it is because batteries are connected in series in all of the batteries. And when you do this, usually the capability of the lowest performing one is going to limit all of the other ones, even if they have more capacity. And this is definitely going to happen because it's inevitable. There is factory settings. Every product has a tolerance. So naturally, not all batteries are going to have exactly the same capacity, same state of charge. And when this happens, the one that has the worst state of charge is going to mark that one for all of the others. Also, temperature differences. If you have a different temperature on one battery and the other, the capacity is going to be different. And also the attenuation difference, meaning that not all batteries, or not all the batteries inside of it will deteriorate at the same rate. So the one that has the worst deterioration is going to be the one marking the limit for all of them, as we can see in this picture here. And in 3 months, you can even get to reach a difference of 12% between one battery and the other. And this is completely avoided due to the smart string solution that we have with the 200 kilowatt hour battery. So when each one of them has an optimizer, even if one of them is at 95%, the others are going to be giving their maximum. If there is an isolation for one, it's not going to affect the others. It's not going to stop all of the battery as it would in other cases. It will just stop that particular one. And this can result to an increase on average of 5% on average for their lifetime. And well, we can see here that this optimizer is built into the pack. So we go to the O&M, operation and maintenance. And this one is important because batteries usually require a lot of maintenance. We are talking about 6 visits a year. And there's not only a cost in this because, well, you have to pay to a technician that has to go to the place and you have to pay him. But also, while this calibration is being performed, that is needed because, as you see, with time, the state of charge, between one battery and the other, there's an increased difference, and you need that to be solved by calibrating. So you have to pay the technician to go there to do the visit. And also, while he's doing that work, that can take up to a day, the battery is not going to be doing any cycles. So that is also lost money. And the cost for our solution is 0 because the state of charge is automatically calibrated when it reaches a certain amount of cycles. It doesn't need an expert to go to the place, so you have to pay for no technical visits. And so it's maintenance free for their whole lifetime, for 10 years. And now, just to finish, we're going to see a little bit of the solutions of how the different configurations that you can have with this system. As we mentioned before, you can have on-grid applications, and also you can also have off-grid applications, so you can have a backup in case of power outage. So for this application, it is for on-grid. It is basically just on-grid operation, and you can have up to 5 batteries connected in parallel. You would need only the Smart IQ, and it would connect with the inverter. And this solution, it is standardized for the M3 inverters, the 30, 36, 40, and 50 KTL, and also for the 100 and 115 M2 and 100 M1. So for these inverters, you can have this solution. It would be connecting the batteries, the smart sensor, the inverter, and the Smart IQ in the system.
Well, let me interrupt you, Alejandro. Smart IQ maybe is not a well-known product. If I talk you about the smart logger, I think it's more familiar for you, maybe. So just to say that this Smart IQ have a smart logger inside. So and also protections and kind of switch, because these batteries needs to be connected via Ethernet cable. These dotted lines in blue are Ethernet connectors. So the smart logger is additionally completed with a switch and other basic elements. But for you to understand what is inside the Smart IQ, mainly is a smart logger. So Huawei performs the energy management system at a basic level by free with the solution. No, you don't need additional third-party energy management system. Alejandro will continue and will explain you when this energy management system from third party is needed. But the good news is that Wattkraft has developed this energy management system that we will put you at this will be available for you. So please, Alejandro, continue.
Of course. Oh, thank you for the intro.
Sorry, Alejandro. Sorry to interrupt you, but Tiago is asking, and I think it's about this this solution, the lifetime estimated.
Lifetime of the battery, yes, because I think you said 10 years.
The 10 years.
But 10 years depends on the number of cycles. So we have a guarantee, a product guarantee that depend. It's like in the domestic battery. So you have a number of energy that you can extract from the battery, and if you do a lot of cycles, 2-3 cycles, maybe it would be 10 years. But if you only perform one cycle, could be longer. 15 years would be a good number, reference number. And also this lifetime is not that at the end of these 10 or 15 years the battery is useless. No, it's the guarantee says that after this period the state of health will be no less than 70%. So you can take advantage of the battery longer, but at this state of health. In other words, you are not going to charge and the same amount of energy as the first day, only 70%.
It's a little bit like the solar panels. When they tell you the lifetime of 25 years, it doesn't mean it stopped producing. It just means they can assure you it's going to be above 80%, and it's the same for the battery.
Exactly. I don't know if this...
Alexandro, Jesus, sorry for interrupt. Just to add, because for Portuguese people, several times they misunderstand the difference between the warranty, product warranty, and life cycle. Okay. So it's a different concept, the life cycle and the warranty. There is a product warranty and there is a life cycle. When the product warranty is over, does not mean that the battery will not function from then. Okay, exactly. So it's better to as you explained, and Alejandro explained very well. So the product has a timeline of warranty, but after that, the battery for sure will keep storing energy, not at the same efficiency, but it will keep doing that. Okay. So it's a different concept between product warranty and
performance.
Performance. Yeah.
And also important to mention, it is at least. So if we're saying 10 years, at least 70%, it doesn't mean it's going to be at 70%. It's just assuring you that it's going to be either that in the worst case scenario or above that.
Exactly. It's a limit, a threshold. Worst case. Let's continue, Mariana, or...
Yes, there's a few questions, but let's the questions to the end of the webinar. It's okay?
Well, yes.
Yeah, you can continue.
Well, so just seeing other configurations for other inverters. This is the other Huawei inverters. This is the official solution. It is using a third-party controller to communicate to smart loggers. One for the Huawei inverter that is not of the models previously mentioned, with the other battery systems. Now, of course, this can be verified for each case. So I wouldn't say if you see this, for example, if you have a configuration you would like to try, or you want to know if it's viable, it is also always worth asking, because we have also our own solutions that we have verified, and we can with other inverters, for example. Also, you can also have the only energy storage system solution. So it is the batteries without the PV. So yes, the batteries work and they don't need to be attached to a PV system to work. And in this case, you can have up to 10 batteries in parallel. So the number here increases. You would need then this smart accu, has the smart logger as I just described, and the smart power sensor, and some PV management system.
In any case, 10 batteries of this size, maybe is better to have a container. You know that in addition to this battery, is for CNI, we have a larger battery, which is 2 megawatt hour, that also we deployed in Spain for some customers. So it's available also for Portuguese market.
Well, exactly, yes. So, you can have 8, 9, but if you want to go to 10, it's better to just have the integrated solution that will also take less space.
Yeah.
Finally, for the off-grid scenario, this is in case that you want to use the batteries in case of a power outage. And in here, also some third-party controller would be needed, but this would be to communicate the, let's call it smart logger, the smart accu, the SACU with the on-off grid switch, so that you can separate the charge that you want to feed and all of the energy system from the grid, and then you can feed these loads off grid, and then to have the connection. So for this case, besides a third-party controller, you would also need a UPS, so basically a battery, so that you can feed management system from the battery, and the smart IQ, and the third-party controller. And well, these are just some of the solutions that can be done. But again, if there's any other configuration that you would like to try that you're interested in, it's always good to ask, because we can evaluate them and we can see the viability and propose ideas. Well, this was the presentation